this question, we will be looking at DC circuits and capacitance. There are two parts to this question. Let's take a look at the first part of the question. What is the approximate resistance between points P and Q, as shown in the circuit diagram in this question? On looking at this question, you will notice that it is difficult to determine whether these three resistors are in series or in parallel. Therefore, we have to redraw the circuit to an arrangement which we can make some sense out of it. So let's draw the resistor between P and X. Then we will draw a connection from point P to Y. Point P to Y is this line here. After which, we will draw the resistor between X and Y, which is given by this resistor, 2 kilo ohm resistor. Then we will draw a connection from X to Q, as indicated by this wire connection here. Finally, we will draw the resistor between Y and Q, which is the 3 kilo ohm resistor. So upon rearranging these three resistors, it will look like this. The three resistors are in parallel. After we have determined that the three resistors between P and Q are in fact a parallel arrangement, let's proceed to calculate the equivalent resistance between points P and Q. The formula to calculate for this equivalent resistance for a parallel arrangement of resistor is given by this formula 1 over R subscript E, where RE is the equivalent resistance for these parallel arrangements of three resistors. And 1 over RE is equal to 1 over 1.0 kilo ohm plus 1 over 2.0 kilo ohms plus 1 over 3.0 kilo ohms. The sum of these three reciprocal values will give us 1.83. Thus, solving for the equivalent resistance for these three resistors in parallel between points P and Q, we will have 0.55 kilo ohm. Let us look at the second part of this question. In the circuit shown below, a capacitor of capacitance 3 microfarad is charged from a battery of EMF 6 volts with the switch connected to terminal P. The switch is then connected to Q. This charges the 6 microfarad capacitor from the 3 microfarad one. What is the new potential difference across the combination? So what happens when the capacitor of capacitance 3 microfarad is charged from a battery of EMF 6 volts with the switch connected to terminal P? Well, charges will be stored in the 3 microfarad capacitor when it is connected to the 6 volt battery. So let's assume that the charge that is stored on the 3 microfarad capacitor to be Q. Take note, 6 volts is connected to the 3 microfarad capacitor, meaning 6 volts will be the potential difference across the 3 microfarad capacitor. And 6 volts is needed to charge up this capacitor to a charge Q. Now what happens when the switch is then connected to Q? the situation will change. Originally, the 3 microfarad has charge Q stored on it. When the switch is connected to Q, part of the charge that is accumulated on the 3 microfarad will be transferred to the 6 microfarad in this manner. So some positive charges that is stored on the 3 microfarad will be transferred to the 6 microfarad capacitor. That's why the question says the 3 microfarad capacitor will charge up the 6 microfarad capacitor. So the charge that's remaining on the 3 microfarad will no longer be Q, but let's say Q1. And assuming Q2 is transferred to the 6 microfarad capacitor. So the sum of Q1 and Q2 will be equal to the original charge, Q, that is stored on the 3 microfarad capacitor. But this transfer of charges from the 3 microfarad capacitor to the 6 microfarad capacitor does not continue forever. It will reach a stage of equilibrium. When is this stage of equilibrium achieved? When the potential difference between the 3 microfarad and the 6 microfarad capacitors are the same. Once the two capacitors have the same potential difference across them, then the transfer of charges from the 3 microfarad capacitor to the 6 microfarad capacitor will stop. And the question wants us to find this new potential difference across the combination. Now, this new potential difference is definitely not equal to 6 volts because 6 volts was originally maintained across the 3 microfarad capacitor when it is storing a charge Q. Now, when part of the charges has already been transferred to the 6 microfarad capacitor, there is no longer charge Q, the original amount of charge remaining on the 3 microfarad capacitor. Hence, the new PD across the 3 microfarad capacitor will definitely be less than 6 volts because 6 volts is needed to maintain charge Q on the 3 microfarad capacitor. Let us proceed to calculate the new potential difference across the combination. Now, first of all, we have to calculate the charge Q that is originally stored in the 3 microfarad capacitor when the switch is connected to terminal P, meaning the charging process of the 3 microfarad capacitor. The charge that's stored in the 3 microfarad capacitor initially before connection to Q is given by this formula. Q equal to C1 V initial, where C1 represents the capacitance and Vi represents the initial PD applied across the 3 microfarad capacitor. So let's substitute in the values to calculate this original charge that is stored in the 3 microfarad capacitor. So C1 is 3 microfarad and Vi is 6 volts. So the product will be 18 microcoulomb. Take note the units for charge is coulomb and the magnitude of the charge that is stored in this 3 microfarad capacitor is 18 microcoulomb. Now, let's proceed to solve the new PD across the combination. Before we do that, let's assume that the new PD across the combination BV. Then, we already know that Q1 plus Q2 is equal to Q. This equation was already explained previously in the question. So the concept is actually known as the conservation of charge, Charges cannot be destroyed nor lost. It has to be conserved. And charge Q, since it was stored during the charging process, it cannot be lost when the 3 microfarad is charging the 6 microfarad capacitor. So together the sum must be Q. Then applying the formula to calculate the charge stored on the capacitors, we have C1 times V to be equal to Q1 and C2 times V to be equal to Q2, and the whole thing will be equal to Q. Because the two capacitors have a common PD, that's why the potential difference multiplied to the two capacitance are the same. So let's do some factorization. So C1 plus C2 whole thing times V is equal to Q. Now, let's substitute in the values that we know. C1 is 3 microfarad, C2 is 6 microfarad. The potential difference V is what we need to find, and the original charge stored in the 3 microfarad capacitor is 18 microcoulomb. Therefore, V is calculated to be 2 volts. I hope with this question, we have a better understanding of circuits. Thank you.